In this video, we're going to be looking at the standard form of the equation of a line, and I'm going to be showing you how to write equations in standard form as well as how to graph them when they're written in standard form. Okay, so a linear equation in standard form is going to follow the format ax plus by equals c, where x and y, of course, are your independent and dependent variables. A, b, and c represent real numbers. Now, the first thing that should jump out at you is that x and y are on the same side of the equal sign in this form, which is very different than slope-intercept form. Okay, so that's the first and foremost rule to follow to put something into standard form. X and Y have to be on the same side. However, there are other rules to follow as well for you to consider the equation in true standard form. The first is that the a value, which is your coefficient on x, it has to be greater than or equal to 0, meaning it has to be a positive value. Okay. Secondly, all three values a, b, and c, they have to be integers, okay, which implies that they cannot be decimals or fractions, okay. If they are decimals or fractions, we're going to have to multiply both sides of the equation by a number in order to change that. All right, and then lastly, final rule to follow is that the GCF, or the greatest common factor of A, B, and C, has to be 1, meaning they can't have anything in common. Okay, if all three of those numbers have a value in common, you have to divide it out. It's kind of like reducing the equation. Okay, so let's write each of the following equations in standard form. First one on the left here, that starts in slope-intercept form. To put it in standard form, I'm going to begin by simply subtracting 3x over to the other side. So this is going to become negative 3x plus y equals negative 6. Okay. Once we get x and y on the same side, run through this list of rules here to see if you are in true standard form or not. And right away, the first rule is being violated. Your a value is negative 3, but I need it to be positive. Okay, so I can pretty easily handle that by simply dividing or multiplying both sides of the equation by negative 1. Okay, that's going to take me here to 3x minus y equals 6. All right, now I check the other two rules. Now that it's positive, I can check are A, B, and C all integers. A is 3, B is negative 1, C is 6. They are integers. We're good there. And their greatest common factor is in fact 1. They don't have anything else in common. So now we're true standard form. Okay. All right, next equation. If I want to put this into standard form, I'll begin by distributing the 1/3 here. And I'm going to move my 1/3 x over to the left, and I'm also going to move the 2 over to the right. So that's going to take me to negative 1/3 x plus y equals 1. Okay. Now x and y are on the same side, but I've got a couple issues. Here I've got an a value that is both negative and a fraction. Okay, so I can handle both of those issues at the same time if I just multiply both sides of the equation by negative 3. That's going to make the equation become 1x minus 3y equals negative 3. So now a is 1, b is negative 3, c is negative 3 as well. Those are all integers, a is positive, and all three of those numbers have a GCF of 1. True standard form. Okay? All right, now, next goal is to be able to graph an equation when it is in standard form. Typically when I ask students to do this, everybody always wants to convert it into slope-intercept form and then graph from there. But the goal is, how can we graph it by keeping it in standard form, okay? And I have a nice interactive applet here to help us see how this can be done, okay? So click this link here. It'll take you to the applet. All right, and I think we can all agree that that equation is in standard form, right? 4x plus 5y equals 20. And basically, rather than converting this to slope-intercept form in order to graph, what I'm going to do is find the x and y intercepts of the line using this equation. Really easy to do when you are in standard form, okay? So I'll find the x-intercept first by plugging 0 in for y. That's the definition of an x-intercept, is that y equals 0. Notice really what that comes down to is, in this particular case, I take the constant of 20 divided by the coefficient on x of 4, and that results in an x-intercept of 5. And now you plot that point. And after you plot the x-intercept, now you find the y-intercept. Find the y-intercept by plugging 0 in for x. In this case, that leads us to the constant of 20 divided by the coefficient of y of 5. That leads us to a y-intercept of 4. Now you plot that point on the y-axis, and we have 2 points here. 2 points is all you need to form your line. And there you go, simple as that. So find the x-intercept, plot that point on the x-axis, find the y-intercept, plot that point on the y-axis, connect the 2 points with your line. Okay. If you go back to your notes and you click on practice 1, you're going to notice there's another link for you to use in order to practice graphing when equations are in standard form. So let's walk through example together here, and then you're going to use it as an opportunity to practice yourself, okay? All right, so here the equation is 5x minus 2y equals 30. You notice we have a box for slope, a box for x-intercept, a box for y-intercept, okay? And then we have the graph below. My suggestion would be find your x and your y-intercepts first. It'll tell you if you've done it correctly or not, and then you can move the white points that are on the line here to the proper locations for the x-intercept and y-intercept, and check the box check graph to see whether you're correct or not, okay? So your x-intercept would be 30 divided by 5, which is 6. Notice it tells me I'm correct. And I can move 1 point to 6 on the x-axis. And then your y-intercept would be negative 15, 30 divided by negative 2. Also correct. And that means I'm going to have to go way down here. And then I'll click check graph. And notice at the top there, it says correct. Okay. In terms of slope, all you need to do is take your y value, your y-intercept, over your x-intercept. So in this case, negative 15 over 6. If I reduce that, divide them both by 3, that's going to be negative 5 over 2. Negative 5 / 2. And I don't know if it gives you a check for that. It doesn't look like it does, but more than anything, I'm concerned with, can you find the proper x-intercept, y-intercept, and make the graph from there, okay? So we can practice this by clicking the green button at the top right that says New Problem. Okay, generates a new equation for you. So I want you to work through a few of these yourself. Use them as an opportunity to practice until you feel you have the concept down. Okay?